Namaste, one and all. As we know, we discussed about in the last classes or last videos, we discussed about the multiple experiments in the simulation of quantum circuits laboratory. The subject code is 21EEL484. The next experiment is that is nothing but design and analysis of op-amp based R2R ladder digital to analog converter. Okay, the aim of the experiments and then operators required and then theory. What do you mean by this R2R digital to analog converter? Here I'm going to use 3-bit digital to analog converter. 3-bit is nothing but 2 to the power of 3, that is nothing but 8. That it will going to give 8 number of input combinations from 000 from 000 from D1, D2, D3, that is nothing but digital inputs 0002 111, that is nothing but 0 to 7, that is nothing but 0 to 7. Okay, it will going to, I'm going to give digital input, the circuit will going to give the analog output, that is nothing but digital to analog converter. Sir, what do you mean by this R to R? Okay, R to R. First, you need to consider R equal to 2R. Okay, R to R. What do you mean by R? What is the resistance we are going to connect in series? That is nothing but R. Okay, what are the resistance I'm going to connect in the parallel? That is nothing but 2R. Okay, what do you mean by R? What are the resistance connected in series? Okay, for example, I'm going to connect the resistance in series, that is nothing but 5 kilo, 5 kilo. What do you mean by 2R? It's nothing but 5 into 2, that is nothing but 10 kilo, 10 kilo, 10 kilo, 10 kilo. That is nothing but R to R ladder network. This R2R ladder network digital analog converter we are going to discuss in this class. Okay, here I'm going to consider design R equivalent is equal to 5 kilo ohm. How this equivalent resistance we need to find? We need to do the series parallel combination calculations. For example, please consider this circuit. Please consider this circuit here. Please consider. I'm going to open my notes. Dear students, first you need to consider this circuit diagram without any values. Okay, first you need to consider this circuit diagram. Okay, D1, D2, D3. D3 is nothing but LSB, and then D1 is nothing but MSB. Now, okay, you know the difference between LSB and MSB. Okay, I'm going to show you in future. Okay, now I'm going to I'm going to put the value. For example, in series resistance, you can take R1 here, R2 here. That is no problem. Okay, R2 is nothing but 5 kilo, R4 is nothing but 5 kilo, R1, R3, R5, R6 is equal to what are the resistance in parallel, that is equal to 10 kilo, and then Rf is equal to 5 kilo. Rf is nothing but R equivalent resistance. R equivalent resistance equal to 5 kilo. Sir, how we should find out this R equivalent? Very simple calculation we need to consider here. Okay, first you need to consider these both resistance. Listen carefully. This resistance, okay, this resistor, sorry, R6 is equal to 10K, this R5 is equal to 10K. These resistance are in parallel. You know the parallel formula, R1, R5 plus R6 divided by R5. You know the parallel formula, R5 into R6 divided by R5 plus R6. Okay, you know the parallel formula, 10 into 10 divided by 10 plus 10 is equal to 5 kilo. Okay, 5 kilo will going to come. That's 5 kilo. This 5 kilo will go to series. Okay, series is nothing but addition. 5 plus 5, 10. Another one time, this 10 and then this 10 will going to be in parallel. Okay, parallel combination is nothing but 10 into 10 divided by 10 plus 10. Answer is 5. Okay, another one time, this 5 kilo will going to, this 5 kilo will going to be in series. 5 plus 5, 10. Here also 10. Another one time, 10 into 10 divided by 10 plus 10. Okay, total equivalent resistance is 5 kilo. This is how we should find out the equivalent resistance. R equivalent is equal to 5 kilo. Okay, then I'm going to assume V reference is equal to 10. If you can take any value, okay, it should be less than 12 volts. Okay, it should be less than 12 volts or 15 volts. Okay, depending upon this VCC and VE, it should be less than 15 volts. Okay, I'm going to consider 10 volts. Okay, 10 volts I'm going to consider, and then equivalent resistance is 5 kilo. Okay, we can easily find out the I. I is equal to V by R formula. I reference is equal to 10 divided by 5. That is nothing but 2 milliampere. We know the output formula, output voltage formula, V0 is equal to IRF into RF. Okay, here we need to consider V0 is equal to IRF. IRF is nothing but reference current into RF. IRF is nothing but we know 2 milliampere. RF equal to R equivalent, that is nothing but 5 kilo. Okay. Now I'm going to consider here V naught is equal to IRF is nothing but VRF divided by R equivalent into F, that is nothing but the output voltage equation. And then you need to consider this digital inputs D1 divided by 2 to the power of 1 plus D2 divided by 2 to the power of 2 plus D3 divided by D2 to the power of 3, that is 842. Okay. Okay. Now, how to fill this tabular column or truth table? Very simple. I'm going to consider this first one 0 0 0. Here I'm going to write 0 0 0. I'm going to directly 1. Okay, 0 0 1. Okay, the first combination is 0 0 1 0 0 1. This D3 will go to on. Okay, that is nothing. What is the current here? 0.25. How this current will going to distribute here? Okay, the reference current is 2 ampere, 2 milliampere. Here there is a two parts. Okay, it will go to divide equivalently. Okay, equally. Okay, 2 divided by 2, that is nothing but 1 milliampere, another 1 milliampere. Otherwise you can apply Ohm's law. Okay, what is the Ohm's law? I is equal to V by R. I is equal to V is nothing but 10 divided by 5, 10 divided by not 5 kilo. Here you need to consider 10 kilo. Why? Because the resistance series parallel combination. Okay, here 10 into 10 divided by 10 plus 10 5. Here 10 5 plus 5 10 10. Here also 10 10. Okay, this is how you need to find out the I value. 10 divided by 10. Here also 10, here also 10. That's why the current will going to divide in same manner. 1 milliampere, 1 milliampere. 1 divided by 2, that is nothing but 0.5, 0.5. 0.5 divided by 2, 0.25, 0.25. This is how the current will going to distribute. Okay, you can find out this way also. 1, that is nothing but this D3 will going to on. What is the current here? 0.25. 0.25, that is nothing but I reference 0.25 into RF. What is the RF? 5 kilo. 5 kilo. 0.25 into 5 kilo, that is nothing but 1.25. Next one 010. Which switch will going to on? D2. Okay, you need to consider this current only because these both switches D1 and D3 are in off condition. Okay, 0.5 into 5 kilo. What is the answer? 2.5. This is how we need to consider. Next one, last one, triple one. Triple one is nothing but all the switches are connected, all the switches are closed. 1 plus 0.5 plus 0.25, 1.75 into 5, that is nothing but 8.75. This is the theoretical value. How we should check the practical value. Okay, this is the theoretical value. This is the yellow color is the theoretical value. Then we need to find out the practical value. How to find out the practical value? Okay, this is the circuit I have simulated already. Already I simulated this circuit. Okay, here you know all the components. How to select the components you know already. Okay, this is nothing but resistance. Connect as per the circuit diagram. Connect as per the circuit diagram. This as per the circuit diagram you should connect. Okay, as per the circuit diagram you are going to connect the circuit diagram in the MULTISIM platform. But here the extra is switch. How to select the switch? Go to the place component and then all groups. Here you need to search DISP. Okay, you need to search DIPS. Sorry, DIPS. You can select anyone. DIPS W3. Okay, we need 3 switches, so that's why I'm going to select D3. Okay, you can select D3. Here A, B, C. A, B, C. You can select anyone. This is how I'm going to select the switch. You know how to select the switch. Okay, and then you can rotate and connect it series with these resistors. Okay, you know all these things. And then what is the another extra component here? Here the multimeter. Okay, how to select this multimeter? Go to the all groups or indicators in this voltmeter V. You can select this voltmeter. Voltmeter. You can do this terminal ground, and then this terminal to output. Okay, you can output or close. Okay, okay. Yes. This is a very simple combination. I know you are going to face difficulty while designing the circuit in the multisim platform, but you need to connect as per the circuit diagram. Very simple. Here the extra component is switch. I already show how to select these switches. Okay, you need to find out you need to search D I T S or put it in all groups DITSW. Okay, this is how you need to select the switch. And then first combination, I'm going to check first combination 000 or 001. Okay, 1 run. Okay, what is the output? 1.66. Here minus will going to show because I'm going to connect the input to the inverting terminal. So you can neglect or consider 1.6675. Here you need to write down 1.665 volts. For 000, that is nothing but 1.38 millivolts, approximately equal to 0. For 001, it shows 1665. Okay, next combination, that is nothing but 010. 010, it shows 2.75. It shows 2.75. You can note down here 2.75. Next 011 run. You need to run after changing switch condition 3.7. Okay, this is how you need to check. I'm going to check directly the last combination, that is number 111. 7.7, I think. 7.7. You need to write here. Actually, practical theoretical value 8.75. Here that shows 7.7. This is how you need to check the output. Okay, very simple. Thank you so much. If you come across any doubts, you can let me know in the comment box. Thank you so much. Very simple configuration or very simple circuit diagram. You can do the circuit for 4-bit also. That is nothing but 2 to the power of 4. That is nothing but 16 combination. Okay, 16 combination from 000 to 1111. Okay, this much is enough for this class. Thank you so much.